Hello, my name is Hannah Patterson. From Experiment 6, I'm going to be explaining and demonstrating with my work on the paper how to calculate percent yield. So first, the first part, we need to find our limiting reactant. So we need to start with some kind of balanced equation. For my example, I chose oxygen and glucose reacting to form carbon dioxide. So in the green up there, you can see my balanced chemical equation. Our next step is to calculate the molar mass of each reactant. So, for example, our one molecule of oxygen contains two oxygen atoms. It's O2. So oxygen's molar mass is about 16 grams. And in order to find the whole molecule's molar mass, we need to multiply our two oxygen atoms times our 16 grams molar mass, and we are left with 32 grams of O2. So for our other reactant, which was glucose, the C6H12O6 has a molar mass of 6 atoms of carbon, and carbon's molar mass is 12, so you multiply your 6 by 12. You add that to 12 atoms of hydrogen, and it's 1 gram molar mass, plus 6 atoms of oxygen, and multiply that by its 16 grams molar mass. And after you do all that work right here, you are left with 180 grams molar mass for this whole glucose molecule. So next we need to convert the amount of each reactant from grams to moles. So we're going to say we started with 40 grams of oxygen, 25 grams of glucose. So we'll have our 40 grams O2 divided by 32 grams, because that's what we figured the O2 molecule's mass was. And once we divide those, we're left with 1.25 moles of oxygen. And then for our 25 grams of glucose, we divide that by our 180 grams of molar mass, and we are left with 0.139 moles of glucose. Next step is to find the ratio of our reactants. So we started with 1.25 moles of oxygen and 0.139 moles of glucose. The ratio of oxygen to glucose, like I have drawn up there in the work, is 1.25 divided by 0.139, and we are left with 9. That means we started with 9 molecules of oxygen for every 1 molecule of glucose. Our next step is to find our ideal ratio for our reaction. So going back to the balanced equation we wrote in the beginning, that tells us our ideal ratio of molecules. So the left side of the equation was 6O2 plus C6H12O6. The coefficients there tell us that there's 6 oxygen molecules and 1 glucose molecule, and that means the ideal ratio for that reaction is 6 oxygen divided by 1 glucose, which is 6. Next step, we need to compare the ratios to find the limiting reactant. So the actual ratio is greater than the ideal ratio, then you have more of the top reactant than you need. So the bottom reactant in the ratio is the limiting reactant. So in the example that we're doing, the actual ratio of oxygen glucose is 9, and that is greater than the ideal ratio, which is 6. The bottom reactant, which is glucose, is the limiting reactant, as you can see here in this green work. So our next step is actually calculating the theoretical yield. So we're going to need to identify our desired products. So the right side of our chemical equation lists the products created by the reaction. So that would be our 6CO2 plus 6H2O. So next, we need to write down the number of moles in our limiting reactant. So in our example, we discovered that glucose was the limiting reactant in our last step, and we calculated that we started with 0.139 moles of our glucose. So next, we need to find the ratio of molecules in our product and our reactant. So our balanced equation is 6O2 plus C6H12O6. And there are 6 molecules of our desired product, carbon dioxide, and 1 molecule of our limiting reactant, which is glucose. The ratio of carbon dioxide to glucose is 6 to 1. In other words, our reaction can produce 6 molecules of carbon dioxide and 1 molecule of glucose. So next, we need to multiply our ratio by the reactants. quantity in moles. So we started with 0.139 moles of glucose, and the ratio of carbon dioxide to glucose is 6. So our theoretical yield of the carbon dioxide is 0.139 moles of glucose times 6 moles carbon dioxide divided by mole of glucose. And we are left with 0.834 moles of our carbon dioxide. So next we need to convert the result to grams. So the molar mass of CO2 is about 44 grams per mole. And you can see in my work here, we need to multiply our 0.834 moles of CO2 times 44 grams molar mass CO2, and that gives us 36.7 grams, which is the theoretical yield of the experiment is 36.7 grams CO2. So now, the bottom part, last step, we are actually going to calculate our percent yield. So we have our actual yield, which was, this is the formula right here, and then basically at the bottom I just plugged it in. So our 29 was our actual yield, CO2, and then our theoretical yield for CO2, which we calculated in this previous step, was 36.7, and once we divide those, we get 0.79, and times that by 100%, we're left with 79% theoretical yield for our CO2. Thank you.